Solve. Determine the exact value of x. So I have two different problems here. I have 2 to the x power plus 20 equals 140, and 10 to the 5x power equals 30. How am I going to solve these and get the exact value of x? My teaching assistant Chloe is here with her latest tips and tricks. She wants you to know that when you see log of a, there really is a 10, we just don't write the 10. So if you have log of 10 and you have a base of 10, because we don't write the 10, those actually cancel each other out and it gives you a 1. Just like when you have natural log of a, there really is natural log of e, we just don't write the e, or you could write it as log base e, we just don't write the e. But when you have natural log of e and the base is also e, they cancel each other out and leave you with a 1. Now the product property of logs is when you have log of m times n, you can go ahead and expand that out into log of m plus log of n. The quotient property of logs is when you have log of m divided by n, you can expand that out to log of m minus log of n, where n cannot equal 0. And the power property of logs is when you have log of n to the p power, you can actually pull that exponent p out in front to p log of m. Now that I have Chloe's tips and tricks, we can go ahead and solve for each of these equations and find the exact value of x. On the first one that I have 2x plus 20 equals 140. If I'm solving for x, I'm going to move everything over to one side of the equation that's not x. So I'm going to start by subtracting that 20 to each side. The 20s will end up canceling on the left, and I get 2x equals 120. From here, I know that logs and exponentials are inverses of each other, so I'm going to go ahead and use the log rules and take log of both sides. So if I take the log of 2x, I have to take the log of 120. Now notice that my x is in that exponent position. If you look at the power property of logs, if I have an exponent like this p, I can go ahead and pull that p out in front. So I'm going to go ahead and pull this x out in front. So I have x times log of 2 equals log of 120. From here, I have to remember that I am trying to solve for x. So I need to just get x by itself. So I am going to go ahead and instead of multiplying by log of 2, I'm going to divide by log of 2 on both sides. So log of 2 will cancel on the left, and I get x equals log of 120 over log of 2. Now on this problem in the directions, it said it wanted the exact value. So I am not going to use my calculator on this one. I just want the exact value. Now on my other problem, I have 10 to the 5x equals 30. We're going to go ahead and use the rules of logs to help us with this problem as well. So I'm going to take log of 10 to the 5x and then take log of 30. Again, I have that 5x in that exponent position, so I'm going to use the power property to pull that out in front. So I really have 5x is multiplied by the log of 10 equals the log of 30. Now, just as a reminder, when you see log of 10, it really has that base of 10, we just don't write it. So I'm going to write that in just to show you that you have log base 10 of 10. When you have log base 10 of 10, or natural log of e times natural log of e, either one of these, it actually equals 1. So this log base 10 of 10 will actually end up equaling 1. So on my next step, I really have 5x times 1 equals log of 30. So I have 5x equals log of 30. Then from here, I'm solving for x. So I'm going to go ahead and divide by 5 on each side. When I do that, the 5s will cancel on the left, and I end up having x equals log of 30 over 5 as my final answer.